All right, so today we're diving into the world of quantum computing, ready to unlock some of its secrets.
Definitely, it's a fascinating field.
It really is, and I think what fascinates everyone is this idea of a computer that can explore tons of different paths all at the same time instead of just one at a time like our everyday computers.
Yeah, it's a completely different way of approaching problems. Unlike our traditional computers that kind of plod along step by step, quantum computers, they use this really wild principle. They use the principles of quantum mechanics.
Quantum mechanics, so that's where the quantums in quantum computing comes from.
Exactly.
Right.
It all boils down to how these computers, how they store and process information. So think about your typical computer, right? It uses bits, which are basically like a light switch. It's either on for 1 or off for 0.
Yeah, makes sense.
With a quantum computer, we're talking about qubits, and this is where things get really, really weird. A qubit can be both 1 and 0 at the same time.
Wait, hold on. How is that even possible? It could be both at the same time.
Yeah, it seems impossible, right?
Yeah, it's like that, that saying, is the glass half full or half empty?
Yeah.
But in this case, it's both.
It's both. And this both at once idea, it's called superposition. It's this really kind of mind-bending principle of quantum mechanics. So instead of our light switch being just on or off, imagine it's like this blurry in-between state. Like it's maybe until we obviously take a look at it.
So it's not even that it's both, it's that it's maybe. We don't even know until we look at it.
That's wild. You know what? I think our listeners are probably feeling the same way right now. It's not every day that you have to rethink how a light switch works.
It's definitely not intuitive, that's for sure.
No, it's not.
But that analogy is actually going to come in handy as we kind of go deeper into how this superposition actually makes quantum computers so powerful.
Okay, so let's get into that then. How does superposition actually make a quantum computer faster than a regular computer? All right, so imagine you're searching for something like a very specific grain of sand, but you're searching on an entire beach.
Okay, I like where this is going.
A normal computer, what's it going to do? It's going to go through each grain of sand one by one until it finds the right one. But a quantum computer, because of superposition, it can actually analyze every single grain of sand at the same time.
So instead of going one by one, a quantum computer can basically just scan the entire beach instantly.
Got it. That's the power of superposition.
Okay, that is incredible. But I have a feeling it gets even crazier.
Oh, there's another layer to this. There's something called entanglement.
Okay, here we go.
So imagine 2 coins, right? And they're flipping in perfect sync with each other no matter how far apart they are. So if one lands on heads, the other one, like magic, it lands on tails instantly.
That sounds like something straight out of, a science fiction movie.
It does, but this is entanglement, and it's real, and it's happening in the quantum world. So basically, in a quantum computer, the qubits can actually be linked in this way.
So they're connected, telepathically.
In a way, yeah. That's how they can share information instantly. And that's another key to how they solve problems so quickly.
Wow. Okay, so we've got superposition, which is like scanning a whole beach at once. And we've got entanglement, which is like having these telepathic coins. I mean, this really is next-level computing.
Hmm.
So with all this power, are we going to see quantum computers replacing our laptops and smartphones anytime soon?
Well, not exactly. It's a little more nuanced than that.
Okay, so you're saying my laptop is safe for now.
For now, yeah.
Okay, so what's the real story here?
It's not that they won't be powerful. It's just they're not really designed for, checking your email or browsing the web.
Okay, so they're not going to replace our laptops,
Right.
but they're not just like a science experiment either, right?
Yeah.
So where do they really excel? What are we talking about here? What kind of problems can these quantum computers solve that our current computers just can't handle?
Right. And I think that table you sent over actually does a really good job of breaking down the differences, right, between classical computers and quantum computers.
Okay, yeah, let's pull that up.
It's a good visual.
Yeah.
So first off, data storage. We already kind of touched on this, but traditional computers, they use bits, those zeros and ones.
Yeah, the on or off.
Exactly. Quantum computers use qubits, which we know can be both 0 and 1 at the same time.
Right, because of that whole superposition thing.
Superposition. Yeah, exactly. Okay, so how about how they actually solve problems?
Yeah, how did that work?
Well, a traditional computer tackles problems one step at a time.
Right, step by step.
Like following a recipe.
Okay.
They're great for things like browsing the internet or editing a document. But quantum computers are different. They explore many different possibilities at the same time.
So they're kind of like working in parallel.
Exactly. And that makes them really, really good at solving these really complex problems like you might find in medicine or materials science.
So it's like, instead of, like, if you were trying to find a specific book in a library, instead of having to go through every single bookshelf, you could somehow, like, look at every book at the same time.
Yeah, that's a good way to put it.
And that's the kind of advantage we're talking about with quantum computers.
Yeah, and think about it like designing a new drug, right?
Yeah.
A normal computer, a classical computer, would have to go through and analyze like each potential molecule one by one.
And that could take forever.
Years, and it would take tons and tons of resources.
Yeah.
A quantum computer, at least in theory, could analyze all the different possible molecules at the same time.
And that would just speed up, like, drug discovery. I mean,
Yeah.
it'd be revolutionary.
Absolutely. And that's just one example.
Yeah. What about, you mentioned, like, materials science. What could we do there?
Well, imagine being able to design a material that's like perfectly suited for a very, very specific job.
Okay.
Or even something like room temperature superconductivity.
Which would be incredible.
Huge.
Yes.
Quantum computers, they could help us do that
Wow.
by helping us really understand and manipulate matter at the smallest level.
Okay, so we're talking about, like, really revolutionizing industries here, potentially.
Oh, absolutely. Energy, transportation, I mean, you name it.
So from life-saving medicine to transforming industries,
Yeah.
it sounds like quantum computing could have a pretty massive impact.
Yeah, if we can get it right.
Okay, so that leads me to my next question. With great power comes great challenges, right? So what are some of the hurdles that researchers are facing when it comes to actually building and using these quantum computers?
Yeah, it's definitely not easy street when it comes to quantum computing.
Okay.
It's still early days, and one of the biggest challenges is just how fragile those qubits really are.
Right, and we're talking about the qubits being the heart of the quantum computer, right?
Yeah, I mean, that's what makes it a quantum computer.
Yeah.
And remember that whole superposition thing we were talking about before, that maybe state? It turns out that keeping that state, keeping that going, requires things to be really, really, really cold.
Okay, how cold are we talking here?
We're talking colder than outer space.
Oh, wow. So this is not just like sticking it in the fridge.
No, not at all.
Okay.
This is extreme cooling.
So how do they even keep these things cold enough to work?
Wow, colder than outer space. So what do they do? Do they like put it in a special freezer or something?
Pretty much, yeah. They use these like super high-tech refrigerators. You could almost think of them like high-tech thermoses, basically.
Mm-hmm.
And they use a process called cryogenics, which is all about extreme cooling, to keep those qubits incredibly cold.
Okay, so we're talking like fractions of a degree above absolute zero here, right?
You got it.
Wow. Okay, that's pretty amazing. But even then, with even if you can keep them that cold, it sounds like it's still really easy to mess things up.
Yeah, for sure. So what happens if a qubit does, like, it heats up a little bit or something bumps it and it's not in that perfect maybe state anymore? Does that just, like, throw off the whole calculation?
It can, yeah.
Oh, no.
And that's actually another huge challenge with quantum computers. They are extremely sensitive.
Yeah.
Even the tiniest little vibration or change in temperature can disrupt the whole thing, and that leads to errors.
So it's kind of like trying to, I don't know, like, build a house of cards in the middle of a windstorm.
Basically.
It just seems like it would be so easy for things to go wrong.
Right.
So how do they deal with these errors then? It sounds like a constant battle to kind of keep everything stable.
Yeah, and that's where error correction comes in.
Oh.
It's one of the like really big areas of research in quantum computing. They're developing these like incredibly complex algorithms and techniques to try and detect when an error happens and then like correct it on the fly.
So it's like having a dedicated team of like tiny quantum mechanics standing by, ready to fix any problems.
Yes. That's pretty wild. But even with these like error correction things in place, it sounds like we're still a ways away from having like, reliable everyday quantum computers.
Yeah, I mean, they're still very much in their early stages of development,
Yeah.
It's going to be a while.
Okay, so we might not be trading in our iPhones just yet, but it sounds like there's a lot of potential here.
Oh, yeah, for sure.
So who are the big players in this field? Like, who should our listeners be keeping an eye on?
Well, the exciting thing is it's not just universities and research labs anymore.
Okay.
We're seeing big tech companies like Google, IBM, Microsoft, they're all investing really, really heavily in quantum computing research.
So it's a real race to the future here.
Oh, yeah.
That's really interesting.
Absolutely.
So for our listeners who maybe want to dive in a little deeper and learn a little more about this, what are some of the the key things that they should be watching out for, following? What are some of the hot topics right now in quantum computing? I'd say one of the most exciting areas is quantum algorithms.
Okay.
So these are algorithms that are designed specifically to run on a quantum computer, and they take advantage of things like superposition and entanglement.
Okay.
They can be used for things like cryptography, materials science, solving those really hard optimization problems.
Right. So things that our current computers really struggle with.
Exactly.
Gotcha. Well, this has been incredible. I feel like I've learned so much about this world of quantum computing. It really is like a whole new universe of possibilities. Like we're on the verge of something really, really groundbreaking.
I think so too. It's a really, really exciting time to be following this.
It really is. And I think the big takeaway here is that this isn't just science fiction anymore.
Yeah.
This is something that is actively being developed, and it has the potential to really revolutionize a lot of different aspects of our lives in the coming years, whether it's medicine, materials, or any other field, really.
Yeah, absolutely. And who knows, maybe someday we'll all have quantum computers in our pockets.
Right. Well, until then, we'll be here keeping an eye on all the latest developments and bringing them to our listeners, so make sure to subscribe and stay tuned, because the quantum revolution is just beginning.